Hi everyone. Um, this is the second lecture for the first day. In my first video, I told you that we are starting calculus today. So if you have been yearning to understand calculus and you are a beginner, so make sure that you join us. So day one, the second lecture. All right. So meaning this is the second video for today. I want to differentiate with respect to x. Yeah, this is a y function. Well, the y function contains x. So this is a function in x. All right. So when we want to differentiate this one, yes, we have different techniques in differentiations. But the thing is, the denominator here is just one term. So we can manipulate so that we can avoid what we call the quotient rule. So to avoid the quotient rule, we start by saying y equal to every term here is divided by x squared. So we say 2x cubed over x squared minus 3x squared over x squared plus 5x over x squared. So we've not done anything like differentiating. Okay, so we say y is equal to 2 divided by 1 is 2. X with a power of 2, x with a power of 3. So these two, x with a power of 2 simply means we have two sets of x. X with a power of 3 is like we have three sets of x. So you can see the numerator will be left with just one x. So we say x minus the same x with powers. So this take away this, it remains 3. So this x will take away one x. There will remain one x here. So we say 5 over x. So the next thing we do is to discourage what? The denominator from having what? A variable. So we say, we go again, 2x minus 3. This is 5. We take x to the numerator. So when we move a variable from the bottom to the top to the bottom, we change the sign of the power. So this power 1 becomes minus 1. Now we can differentiate. So we say y over x. The power of x is 1. Remember, when you cannot see 1, so you cannot see any power, it means the power is 1. So 1 times 2 is 2. You write the variable. When we are differentiating, the power must always lose 1. So the power here 1, then we take away 1, that will remain 0 minus. This term does not contain this x, so that makes it a constant. Differentiating a constant will give us 0. So this is 0. Okay. The power is minus 1. The coefficient is 5. So minus 1 times 5 minus 5. Remember, we must always say minus 1. Here is already minus 1. Then if we say again minus 1, we say what? Minus 2. So this is 2. Remember, from basic indices, any value raised to the power 0 is 1. So we can choose not to write 0 again. So we come to this minus 5x to the minus 2. So 2 times 1 is 2 minus 5x to the minus 2. This is our result. But sometimes the teacher will choose to say what? Leaving what? Positive powers of x. So if the instruction says your derivative, your differential equation, your differential coefficient must contain only positive powers, then we say 2 minus 5 over, you bring this x down. Remember, we change the sign of the power. X to the power minus 2. So this is what we finally get. The second one is here. We have a denominator that contains what? A variable x. So the first thing we do, now we say y, just like what we did here. We separate the denominator. So this takes this, and also this one here. So we don't want the denominator to contain x, and we can do it. Why? Because the denominator is just a single term. If it is like this, then we cannot do anything. Yes, there is something else we can do. I think that's what we call the quotient rule. But in the subsequent videos, then we can learn what we call quotient rule. So the next thing we do is x over the root of any value, be it a constant or a variable, is that value raised to the power half. The square root of any value is that value raised to the power half. So plus 5 over x to the half. So we keep going. So we have x here at the top. The numerator is x. Here again is x. So because of the same thing we have here, x, we write 1. For the x at the top here, there is 1. And 1 at the bottom, there is half. Moving this power to the top, the sign changes to minus half plus 5 and x, they are not the same. So we cannot do what we did here. So we write 5 and we'll bring this one up there, which is the sign of the power. Here we do not need to write the 2x. We write only 1x. And with that 1x, the power here is 1. When this power goes up, the sign of that power changes. Remember, moving a variable, moving a base, moving a value from denominator to numerator, numerator to denominator, you need to change the sign of the power. So here we say y is x raised to the power 1 minus half. It remains half. You have one piece of cake and you decide to give away half of that cake. That will remain half. Plus 5x raised to minus half. Now we can differentiate now. A y function in terms of x. So we say dy dx. The coefficient here is 1 because we don't see anything. It means 1. So half times this one is half. Now the next thing we do is the power minus 1. We must always say this word. The power, having said the power times the coefficient, then the next thing we do is the power minus 1. So the power minus 1. So the next again, the power times the coefficients, minus half times 5, minus half times 5. What do we do? 1 times 5 is 5, 2 times 1 is 2, minus times plus is minus. So minus 5 over 2. Let's don't forget to write the base. Then finally, the power minus 1. So the power here minus 1. So we keep going. Half x. 4 minus 3 is positive 1. So 3 minus 4 is negative 1. So if 1 minus half is half, then half minus 1 is negative half. Remember, 1 minus half is 1 because bigger minus smaller. Now, smaller minus bigger. So we say minus half. minus 5 over 2x. Now here, minus half minus 1. Minus 3 minus 2 is minus 5. Minus 10 minus 2 is minus 12. What is the pattern here? We add, then we take common sign. We add, we take common sign. So minus half minus 1, we add. So when we add half and 1, you have one piece of cake. Your friend gives you half piece of cake. You now have what? 1 and a half. So we have 1 and a half. We take common sign. So we say minus 1 and a half. You leave it this way, it's normal, it's okay. So we say half x to negative half minus 5 over 2. So 2 times 1 is 2. 2 plus 1 is 3. 3 over 2. So negative 3 over 2. So this is what we have, which is correct. Right from this point, it is correct, except if your teacher asks you to leave the answer with what? Positive indices. Let's see what we do here again. The first we do is to say y equal to root 3x minus, yes, 1 over 3 root x. 3 root x. So what do we do with 3 root x? Okay, the first thing we do, remember, square root of any value is that value raised to half. Is that value raised to what? Half. Or if you want, we can say, root 3 times root x minus 1 over 3 root x. But the problem here is we don't want the denominator to have the variable. And we have only one denominator, which is not an expression. So we can disorganize that one. So we can say this is root 3 x is x to the half. Square root of a value is that value raised to power half. This is not a variable. The reason we don't do it here, minus 1 over 3 x raised to half. So we keep going. The root of 3 x raised to half minus. So what do? We usually move the denominators with variables to the top. So we can do the same here to the top. 3 is not a variable, so we don't bother to move the 3. So only this one goes up. X raised to minus half over 3. It seems this one has disappeared. No, it is here. When you don't say anything in front of a letter, a variable, it means there is one. So now we can differentiate. Or one more step before we differentiate. Root 3 x to the half. There is one here. 1 over 3 x raised to minus half. So no more variable at denominator position. So now we can say dy dx, yes, the power is half. The coefficient is root 3. So what do we say? We say root 3 over 2, because half times root 3. Remember, there is 1 here. 1 times root 3 is root 3. 2 times 1 is 2. Then differentiating, the power multiplies the coefficient. Look at it. Then we have the variable. Then finally, the power minus 1. The power is this minus 1. So this is minus. Now again, the power is minus half times the coefficient is minus 1/3. Minus times minus will give us plus. 1 times 1 is 1. 2 times 3 is 6. Then we say x. Let us don't forget the final thing we do. The power minus 1. So from here, we can say root of 3 over 2 minus half minus 1 minus 1/2, which is minus 3 over 2. So this is minus 3 over 2 plus 1/6 minus half. Oh, this is not minus. This is half minus 1. If someone asks you 3 minus 5, just say it's the same as minus 5 plus 3. Yes, 3 minus 5 is the same as minus 5 plus 3. So half minus 1, we did it somewhere here. Oh, this is 1 minus half. Okay, half minus 1. Okay, look at it. Half minus 1. Half minus 1 is minus half. So this is minus half. Minus half minus 1. Minus half minus 1 is what we get this one here. So minus 3 over 2. So this is what we have. If you want to try any one, then let's say you try this. 2x over the root of x. Then you tell me what you have in the comment section. Thank you for watching. Don't forget to like and share. Bye bye.